Everybody get shaken up. I probably had students on there going, "What's going on with the live stream here?" All right. Amateur hour up here today. Man, I tell you. Oh, I downloaded it 3 times. Get off of there. Okay. Yeah, sorry about that. Man, when you have to go back and forth and you only have a couple minutes to get ready, and then your train doesn't want to stop, even though you turned off the computer. That's a good one. I haven't. As we get started, you know that the homework is up. It's due this weekend. It's work at your own pace, open note, open anything. It's just doing the mastering stuff. And the homework is worth a lot of points too. So even though your tests are online, your homeworks are also online as well. So that should be kind of helpful, I think, to you guys. A little less stress in our life. Okay. So yesterday we talked about epithelial tissues, and I'm sure you're already starting to notice something about A&P, something I'm sure most of you were already aware of: the jargon, the names, lots of memorization. Now I know that your tests are online, so there's this thing where we don't have to study as hard, and it's nice. We don't have as much stress, and we'll probably make better scores, which is fine. What I would suggest doing is still trying to sit down and memorize this stuff. The beautiful thing about your test being online, open book, open note, I don't care. I do care that you learn it, but you have a low stakes ability to go in there and see how much of it you actually memorized. You can try learning it without being nailed, because you can always go look the answer up if you don't know it. Good? But I'm just trying to encourage you to study this a little bit every day, because if you do go into medicine, nursing, or whatever, you're going to have licensing exams, and they're going to ask you about this material. And if you don't know it, you're not going to do too well. And if you go into A&P 2, your tests are almost certainly going to be in class again. And if you haven't developed the study skills of well, how do we memorize all the different types of epithelial tissues, right? How do I remember squamous and cuboidal and columnar cells, and whether or not they're simple or stratified? You got to make sure you know that, okay? So I'm just trying to help you out here. I just encourage you to study, even though there's not a lot of pressure to do so. But I think if you want to go into medicine, you need to work on it on your own. You need to be self-motivated. Okay, that's my getting pumped up talk. Don't take it lightly. I know everybody's breathing a sigh of relief knowing the tests are online. And if I was sitting in your chair, I'd be like, man, thank you. I always preferred the on or take home test, because I always felt like they were way less stressful, even though they were harder. Okay. So as I just mentioned, there's different strategies for memorizing lots of different types of information. And unless you have a very, very good memory, and I have come across people that have ridiculous memories, I am not one of them. So the way I have to start memorizing this stuff, and honestly, A&P is not what I normally teach, but I still have to learn it. So how do I go about wow, we just went over all these epithelial tissues. What in the world? There's squamous and columnar and cuboidal and simple and keratinized and non-keratinized, and all of these things start to jumble up if we're not careful. One of the ways I like to think about it is hierarchical. This is just one way I do this. And so I know I'm studying epithelial tissues, right? And there's 4 of them. We got 4 types of tissues, remember? So you go, okay, we got epithelial, we got muscle, we got nervous, and we have connective. Okay, now we're going to talk about epithelial tissues. All right. Well, epithelial tissues can be one layer, single cell, right? That's simple. Or they could be multiple layers. That's stratified. Okay, now we memorized a couple of things here, right? It's either in one layer or it's in multiple layers. It's either simple or stratified. Okay, now we've got 3 basic cell types. What are those three basic cell types? Squamous, cuboidal, and columnar. So we're going from flat to cube to column. Okay, I got my three different cell types. I can be either simple or I can be stratified. So now I can have simple squamous. I can have simple cube. I can have simple columnar. Right? Now let's memorize a whole bunch of different types of way epithelial tissue can be. And whether or not you're flat, well, if you're flat like squamous, wow, that means that you can have rapid diffusion across you. So where might you find that? Where might you find a simple epithelial, a layer of epithelial cells that's simple with squamous cells? Lungs, right? Because you need rapid diffusion of oxygen and carbon dioxide across your lungs. And I mean, if you don't think it's rapid, I mean, just stand up and walk across the room really quick. You'll start breathing that fast, right? So you'll need it very quickly. Okay. Well, you've also got, so you've got those three, and then we can come down and start looking at the epithelial cells here. And you can have stratified strata, layers, right? And you can now have stratified squamous, stratified cuboidal, and stratified columnar. Okay? So you start to see how you kind of start off with, we have epithelial cells, you're stratified, you're simple, you got three different cell types, and you see all the different permutations of that, right? Okay. All right. I have to admit that these tables that are in the textbook, I don't know, how many of you actually owned a hard copy of the textbook? Yeah, are you guys studying okay with the textbook online? Yeah, that is a huge difference between my generation and your generation. I'm glad you guys can. I'm so old school. I love books. I got to have a book in front of me to study. I was going to say one thing you could do is if you don't want to buy the book, is to print the PowerPoints out. That's a cheap way of having basically the book, because we've used all the PowerPoints are basically right from the book, so that might help you out if you need a hard copy. Okay, but what I was going to say is that I do really like these tables, and these tables do exactly what I just showed you as a way of like learning a hierarchy, and then you have all these permutations. So this one right here, this is the simple epithelia, one cell layered, and you can have the squamous cells, the cuboidal cells, and then the columnar cells. And then of course, you've got the pseudo-stratified. And no matter what you do, there's going to be memorization. And if you memorize a few root words, pseudo, well, what does pseudo mean? False, right, or faux. Those right there tell you it looks like it's stratified, but it's not. And the reason why it looks stratified is because the cell nuclei are in different areas. And basically, this is where you get, and like in your nasal passages in here, you get trachea, and cilia. They're secreting mucus. Then, of course, here's where you have your stratified epithelial cells, and then you have the permutations. You've got squamous, and of course, you can have now keratinized. And keratin is what? It's your skin, yeah. Well, that's the keratin. You're absolutely right. It lacks nucleus. But keratin, remember, that's one of your three types of cytoskeleton. These are permanent members of the cytoskeleton, very strong, very permanent structures. So if I've got stratified epithelia, think like rock strata, layers, and it's keratinized, non-nucleated, it lacks a nucleus, and there's squamous cells. Then you can have non-keratinized, which means they have a nucleus. And whenever you see anything with a nucleus in it, you know that that's an active live cell. And in this case, it's doing mucus. Then, of course, you can have stratified cuboidal, stratified columnar. Good? So you start learning just 2 or 3 different things, then you can do these different permutations of it, and next thing you know, you've just memorized 10 different types of epithelia. That's how I do it. That's one way. Okay. And then yesterday, we stopped at the glandular epithelia cells. Now, glandular is basically, these are glands, and they're going to be secreting something. And these are part of our epithelial cells. They might not always be on the surface. They may have migrated to other parts, and then they secrete using ducts. So for example, in your epithelial cells, one of the most common ones are the goblet cells. And goblet cells, I guess because they look like a goblet, it's amazing how we name things sometimes just based on the way they look. They're unicellular, and they're what they call exocrine glands. Exo just means like outward. And they basically, that's where your mucus comes from. Yeah.
And what's that unicellular again?
Unicellular? One cell. It's a single-celled exocrine gland. It's just one cell. A lot of these glands are like multiple cells. But these are, they line your epithelium and they just release lots of mucus. So when you get sick, you release more and more mucus, and your cilia beat back and forth to remove it. So it traps stuff. Okay. And of course, mucus keeps things nice and moist too. And mucus is pretty wild stuff. It can dry, and around some animals, they'll actually like line themselves in mucus that will dry, and it creates an impermeable barrier and will keep them moist inside. It's mucus. Yep. It's not. Okay. So endocrine glands, I know that says exocrine, but endocrine glands, these secrete hormones directly into your blood. Did I just have it here? So if you talk about your endocrine system, you're secreting hormones directly into your blood, and these can have kind of like a longer lasting effect, and you can transmit it throughout different parts of your body. So for example, things like growth hormones, oxytocin, testosterone, the different types of estrogen. These are examples of hormones. Hormones, of course, are long-distance signaling molecules. So you can release a hormone like in your kidneys, and it can affect your muscles, your heart, your digestive system, right? You can have all these cascading effects. You can release, from your endocrine system, it'll travel throughout your blood, and as long as you have some receptor for that signaling molecule, it will affect some response. Does that make sense? You have to have a receptor for the hormone, like growth hormones and things like that. If your cells don't have the receptor for the hormone, nothing will happen. It's like right now, like, what is it? 104, what's the channel? 104.7, all the radio stations in town, the radio waves are flowing right through us right now. All of our cell phone microwaves are flowing through us right now. We're not hearing any of it. At least I hope not. But you hear it if you're tuned into it. So if you have a proper receptor, you can tune into it. Does that make sense? Your cells are the same way. You have lots of hormones constantly floating through your body right now in your blood from your endocrine system. It's just you have to have a receptor to get that. We also have exocrine glands. These are multicellular glands, okay? And they can be arranged in different ways. And basically, you notice there's merocrine and holocrine glands. And the way that these work, these, of course, are exocrine glands, and they're releasing stuff onto the apical surfaces of your epithelia. Wow, that was a lot of words, right? The apical surface of your epithelia. What does apical mean? At the top, right? So like an exocrine gland might be releasing stuff onto your skin, onto the surface of whatever epithelial lining you have. At any rate, I know the book has a different one, a third one, but for here, we need these two, merocrine and holocrine. American, what they're going to do is you're going to create your whatever you're going to excrete inside the cytoplasm. And if it's proteins or whatever, it's going to go through the endomembrane system. It's going to go to a transport vesicle, and it's going to go to the surface of the cell, and the cell is going to release it. Exocytosis, right? It's going to release it. So those cells are excretory cells. They're going to release it into this area. And here, it's going to go out the top. And that's pretty common. The other one is the holocrine. And this one, the cells will actually make what it's going to excrete. And in this case, the cells, if it's going to release like sebum, which is oils, like on your skin, then it's going to like the entire cell is going to come out, rupture, and release all the oil. So like if you get like oil on your skin, that's where it's coming from. And of course, you have dust mites and little mites that live on your face and in your eyebrows. If you get a little itchy, they're probably on there eating your skin away, living on the oil. Oil's got lots of energy. Boy, do you feel a little itchy right now, knowing you got dust mites all in your? I think that's I'm sorry you're allergic to my poo. It's a little dust mite. But you're, of course, inhaling right now. I mean, we inhale all kinds of things, right? That should have gone right there. Okay. Unfortunately, most of us will be impacted by cancer form, whether it's a family member or ourselves. Cancer is when a cell becomes damaged through mutations, and it can no longer regulate itself. It basically evades programmed cell death, can evade your immune system. It loses its identity as whatever cell it was, and escapes all the checks of the cell cycle. And the cell cycle, as you know, the cell goes through division, and then it's got these checkpoints that have to make sure that the cell is healthy enough, has enough energy, isn't damaged, and these checkpoints will stop cells from dividing if they're damaged and repair that damage, or actually the cell will kill itself. In cancerous cells, they've kind of lost their identity as an epithelial cell or whatever type of cell. They no longer they just bypass those checkpoints, and they reproduce their damaged DNA, and they don't repair their DNA. So it takes mutations for cells to evade that. And then they also evade the programmed cell death as well. And a lot of cancers that are common are cancers that arise from our epithelial cells. Anybody know why? Yeah, they're subject to everything, right? Like it's your epithelial cells, like your skin is constantly exposed to sunlight, and whatever you dump on it, right? Whatever you inhale, you breathe. Like smoking lung cancer is by far the most preventable cancer in the world. Okay, easily just don't smoke, or don't live in polluted cities. Like people have a mouth all the way down to your anus. I mean, you've got your entire digestive system is exposed to everything that you eat, right? So if you're eating, like a lot of food that's high in fats and salts, that can lead to increased risk of cancer. Same with alcohol. If you're got toxins in your environment that are on your foods, that's not good. That can lead to problems as well. So your epithelial cells are exposed to all kinds of things in your environment that are called carcinogens. And carcinogens are things that cause cancer. The way they cause cancer is they damage the DNA in these epithelial cells. Not only that, as I've told you, you lose approximately 50 billion cells every single day. That's normal. Old cells they die and they're gone. And that way you make room for new cells. So if your epithelial linings are constantly being bombarded by stuff, well, the basal cells, they can accumulate mutations and they become cancerous over time. So it's a double whammy, right? They're reproducing all the time. Every time you reproduce, there's potential for mutations, right? And then you're exposing it to carcinogens that can increase the rate of mutations. Some cancers, some of the time. And I put a lot of caveats in there. And a carcinoma is a type of cancer that you get. It's an epithelial cancer, like lung cancer. And really quickly, I don't know what you guys know about it, but cancer, there'll never or will unlikely be a cure for cancer, because cancer is a catch-all term for about 100 different diseases. That's pretty wild, isn't it? I mean, we talk about cancer, but there's like 100 different diseases that cause cancer. I mean, for just example, you can have breast cancer, and you could have two women come in with like the same stage of like stage 2 breast cancer. They go through the same treatment. One lives for 30 years, one dies in 6 months. Sad. The difference is then that can happen is you might lose the ability to repair your DNA. And if you do that, that's not good. Any questions? All right. Tissues, which degrade as you get older. That's so sad. Tissue. So here's our hierarchy, right? We've got our epithelial cells, connective tissue, muscle, nerve, specialized connective tissue. Okay. And then their functions. Well, they hold us. Also use them for support and protection as well. And transport. So anybody at home, we're on slide number 37. So we got, you might not think of this, but blood is actually part of your connective tissue. They provide us support, hold us, give us our shape. They also provide protection of bones. And connect. Well, if you have loose, you probably have the opposite of that, which would be dense. And then we have reticulum. Cells like fibroblasts. Now, whenever you see the word but these cells are active. They're doing something, like the collagen and the elastins and things like that. Hepatocytes, phagocytes. Phago means eating, cells that eat. And then, of course, we have other immune cells that are part of the fibroblasts. Oh, come on. These cells, the collagen proteins. And, of course, collagen is that protein that holds us together, basically. There's our nucleus. That means that's our cell. And then we can see the extracellular. Okay. All right. We also have Adipocytes. These are basically fat cells. The reason why they're white is because they are filled up with lipids, specifically triglycerides. Make sure I got that right. Yeah. Okay. So these cells, what's interesting about them is about the time you're a young kid, like I don't know the exact age, but pre-adolescent, you basically have, for the most part, all the adipocytes that you're going to have, all of the fat cells you're going to have. Now, as you get older, as you get in your 20s, your 30s, your 40s, your 50s, don't worry. Your metabolism is not slowing down as much as you think. You're just not moving around as much as you think you are. And we accumulate fat over time. We accumulate fat in our adipocytes, and those cells get larger and 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 larger. So, but you can, as a young child, add on adipocytes. Does that tell you a problem about being really little and being fat? Yeah. Yeah, if you're a little bitty kid and you're being overfed and you can actually add on more fat cells, which makes it even easier to maintain obesity into adulthood. Okay, the other ones are the mast cells. So a lot of cells in your connective tissue don't move around. Like a fibroblast is just not going to move around that much. But your immune system will move around. It's parts of your cells of your immune system. And in fact, they're actually moving around looking for things. So these mast cells, if you notice, there's all these granules in there. They carry chemicals required for your immune system, including things like histamines, which cause an inflammatory response. And those histamines will actually bring parts of your immune system there to like attack a foreign invader or something that's there. So whenever you take an antihistamine like Benadryl, you go to sleep. But you also it helps reduce inflammation. And chronic inflammation is a really bad thing for us to experience. It's you don't want to have chronic inflammation for a long time. And then in the connective tissue proper, we also have these things called phagocytes. Phago just means like eating. And these cells are, of course, they're capable of phagocytosis. It's a really, really remarkable process that a cell can do. There are so many things involved with phagocytosis at the cellular level that we just see this cell just like engulfing another cell and we're like, oh, cool. Right? Or at least some of us do. I mean, the others are like, whatever, you know. But if you think about like the coordination that's involved with that, with a phagocyte. So basically, phagocytes will roam around your body and they'll take out a damage, right? And then, so our phagocytes actually have receptors that can read that signal of a damaged cell, whether that cell is becoming cancerous or it's got a viral infection, right? And it will go there. And not only will it detect it, there's all of these changes that take place in its cytoskeleton, the microtubules, the actin filaments. They have to take the membrane and move it around the damaged cell or the parts of the cell or the bacteria or whatever it's attacking. So it moves it all around her, and then it will actually pinch off that cell into a vesicle inside the cell, right? It could be a large vesicle, right? And then like the lysosomes won't just wander up to it, they're actually directed to it. And then the lysosomes will go up there and butt into it and release all of these digestive enzymes. And you release things like proteases. ACE means enzyme. Proteases break down proteins. Lipases, some lipases like break down lipids. Nucleases break down DNA. So they'll start chopping these things up. So it's like I said, there is an enormous amount of stuff that takes place inside of a macrophage as it goes to take out a cancer cell, a cell that's damaged. Because like I said, if a cell is becoming cancerous or is invaded by a virus, I think we teach a class here at UNM on immunology. It's in our bio departments. Pretty popular classes. Okay, so we talked about the different cell types of connective tissue proper. Right, the fibroblasts, the adipocytes, the phagocytes. Now there are 4 basic types of this connective tissue: loose, dense, reticular, and of course the fibroblasts, the primary cells of these. And remember, fibroblast, blast meaning it's like an immature cell, fibro, like making fiber, they're making the collagen fibers, the elastin fibers, they're making most of the ECM here, okay? And then of course adipose tissue, and the primary cell there would be the adipocyte. Good? Okay. Okay. So now we have the loose connective tissue. And of course, you can see the diagrams here. It's got the fibroblast. You can always see the fibroblast. There's your nucleus, that dark purple there. And then that's a cell around it. And then you've got collagen fibers. What macromolecule is made of that makes it collagen? Yeah, exactly, proteins. What about the elastin fibers? Proteins, right? It's all proteins. It's like the world is proteins, isn't it? So those fibroblasts, what they're doing is they're synthesizing collagen, elastin, all 3 of these different types of fibers, and they're making them through their endomembrane system, then exporting them outside the cell. What I don't know, which was I found interesting, is how are these cells exporting these proteins out, which we kind of know, but how are they getting them to form the actual fibers outside the cell, which to me is kind of interesting. Okay, so this loose connective tissue is found beneath the epithelium of your skin, so it's just on the basal layer. It's pretty stretchy, and you also find it within the walls of your organs, your hollow organs anyways. And it has blood vessels. And whenever you know that there's blood vessels getting in there, that means those cells are active. They can get nutrients. They can remove waste. These cells are actively, reproducing, building stuff as well. And you guys have actually seen loose connective tissue if you eat meat. If you're a vegetarian, maybe not. But if you ever okay. So we got loose connective tissue. Now we've got dense connective tissue. There's also fibrous connective tissue. This is also, it's just deeper in the skin for areas that are very high tension. So you think about your skin, think about all the things your skin deals with. I mean, you can yank on the skin pretty hard, right? And the reason why and it's also, like I said, it's very important. All right. And the other thing is with that tissue is you can pull your skin in almost any direction. Now, we also have dense, regular connective tissue. And if you notice here, the collagen is in layers. And they're all parallel to each other. This to the bone, and then your ligaments hold your bones together, right? But every joint you have, so what that does is by being in layers like that, it's nice and stretching this one way, but not so much this way. And you start snapping tendons immediately. Fortunately, we have ways of fixing that. I had a roommate in college. She broke the right one twice and her left one of once, 3 ACL surgeries, and I was like, well, maybe you need to rethink playing ultimate frisbee there. You're not even on scholarship. It's just something to think about. But yeah, so the other problem with that is when you do tear it, or if you notice, they're all almost stacked up. They're all nice and regular.